Hi, in this video we are still going to learn about inverses of functions, but at the end of the video you should be able to determine if two given functions are inverse of each other. How do we know if two functions are inverse of each other? First and foremost, a function can only have an inverse of it if it is one-to-one. You can use the horizontal line test on a graphical representation to see if the function is one-to-one. It should only intersect the vertical line once, the graph of the given function. If it's indeed a function, then there is an inverse that exists of a given function. Now, we are supposed to learn already how to perform composition. How is composition applied in inverse of function? In the definition here, if function f and function g are given such that f composed of g of x is the same with the result given g composed of f of x, and that both have the same result of x, then the function f and function g are inverses of one another. What does this mean? If you are going to perform composition of g of x and then it results to x, it's going to be the same if you perform g composed of f of x. If both or either one results to x, because either way it will be equal to x, then we can conclude that the given functions are inverse of each other. If the result is not x, it could be 2x, x plus 2, then or something else, then the two given functions are not inverse of each other. It's very strict. After performing composition of function, the result is supposed to be x for you to be able to determine that the given function are inverse of one another. Now, let's have the example. Show that the following are inverses of each other. Given function f of x is equal to 7x minus 2 and g of x is equal to 1 over 7x plus 2 over 7. What do we do? First, we can try your f composed of g of x. This means that in the function f, the x function is the whole value of g. Will be plugged in here. As to show work, here it is. So in the function f, the x is going to be the g of x. And now let's proceed. You have 1 over 7x plus 2 over 7, which is the value of g of x. And then after performing this part, you can now do PEMDAS. 7 times 1 over 7 is 1, because 7 times 7 is 1. 7 times 1 is 7, divided by 7 is 1. So you have 1x. Next, 7 times 2 is 14, divided by 7 is 2. So you have x plus 2 as a result of your distributive property, and then copy minus 2. There it is. Again, 7 times 1 is 7, divided by 7 is 1x. 7 times 2 is 14, 14 divided by 7 is 2. Minus 2, you just copy, but 2 minus 2 is 0. Therefore, your result is x. And therefore, they are then inverse of each other. Now, let's try to show g composed of f of x, which means it's the reverse this time. Let me erase. In your g function, the f is going to be the value of the x in the g function. We will plug in f of x, which is 7x minus 2 in the g function. Here it is. And then start performing your distributive property. 1 times 7 is 7 over 7 is 1. 1 times negative 2 is negative 2 over 7. So actually, you have 1x and then negative 2 over 7, and then copy 2 plus 7. It looks complicated, but actually this part is going to be equal to 0. It cancels out. Again, the result is actually x. Like in the definition, it was shown in the formula, f composed of g of x is equal to g composed of f of x is equal to x. It means you don't have to show both work. You can either choose one if the answer is x. Therefore, they are inverse of each other. Since the composition of each both produce value of x, therefore they are inverses of each other. Let's try another example. You have here our function f and g are inverses. Given f of x is equal to 3x minus 2, g of x is equal to x plus 2 over 3. Let's try your f composed of g of x, which means in your f function, this will be your x. G of x is x plus 2 over 3, so we will replace that one and start your PEMDAS rule. 3 times x, 3x, divided by 3 is x. 3 times 2 is 6, 6 divided by 3 is 2. So actually, it's cancelled. It's just x plus 2, and then copy x minus 2. 2 minus 2 is 0, you have an x, and therefore, the function f and g are inverse of each other. For the sake, we can actually show also g composed of f of x, which means it's the reverse this time. Your 3x minus 2 is going to be your x value in your g function. So your f of x will become 3x minus 2. And then looking at the work, you could actually just cancel this one because it's equal to 0. And so you have 3x over 3 as a result. You can now cancel 3 divided by 3 because it's actually just equal to 1. And again, it's equal to x. And therefore, indeed, f and g are inverses of each other. Remember, the only reason why the two functions are not inverses of each other is that if your composition does not have a result of x, then they are not inverse. If the result is x, either f composed of g of x or g composed of f of x. If the result is x, then they are inverse of each other. Let's have another. I guess this is the last example. It looks complicated, but we can try. Your function f of x is equal to x cubed minus 4, and g of x is equal to the cube root of x plus 4. Let's try your f composed of g of x, which means in your f function, your x is the value of cube root of x plus 4. We are going to plug in your g of x inside the cube, so you have cube root of x plus 4. It looks complicated, but actually it's a very simple logic. Since cube root is opposite of cube, then they cancel out. What you have left is actually x plus 4. The cube root includes this whole radical symbol. Again, the opposite of cube root is cube. The opposite of square root is square. The opposite of fourth root is power of 4. They cancel each other. So you have x plus 4 minus 4. And so 4 minus 4 is 0. And so your result is x. And therefore, without even doing your g composed of f of x, we can conclude that function f and function g are inverse of each other. But for the sake, let's show g composed of f of x. And now it's a reverse. You're going to plug in the function x minus 3, x cubed minus 4 in the x of g function. So we are going to plug in your x cubed minus 4 to replace your f of x. You don't have to perform your cube root and cube yet. you could actually cancel your negative 4 plus 4. It's actually 0. After cancelling it out, what you have left is cube root of x cubed. Again, cube root is opposite of cube. And so they cancel each other, and what you have left is x. You don't have to show both. You can either choose f composed of g of x or g composed of f of x. And if the result is x, then the given are both inverse of each other. If the result is not x, again, if the result is not x, like 2x, 3x, x is understood as 1x. If you have x, then they are inverse of each other as a result. If the result is 2x, 3x, or x plus 1, x plus 2, x minus 2, x minus 3, not just simple 1x, then they are not inverse of each other. Okay? So, therefore, the given are function f and function g are inverse of each other. I guess that's the last example. Oh, here's the challenge. There is no work given. What do you think? Show that f of x is equal to 4x minus 3 and g of x is equal to 1/4 x plus 3/4. Show that they are inverse of each other. To show, actually, if you're going to solve, f composed of g of x will have the same answer with g composed of f of x. Actually, they are inverse of each other. The result will be x, and then therefore they are inverse of each other. Okay? And that's it. You should have learned, at the end of this video, you should have learned how to determine if the two given functions are inverse of each other. The result of your composition, either f composed of g of x or g composed of f of x, should be equal to x to be able to say that the given are inverses of each other. Thank you.